Hello and welcome yet again to my YouTube channel, the hub where we take the concepts of science from complex to simple. And today's episode, we're dealing with yet another question, balancing a chemical equation using the algebraic method. And if you're new here, my name is David. I'm the billionaire teacher who takes the mystery out of chemistry so you can make history. It's been a week-long series of multiple videos showing us the step-by-step nitty-gritties of balancing a chemical equation, and today we're solving yet another question. So let's get into what we have for today's video. So using the algebraic method, the first thing to do is to assign letters to represent the coefficients that should be in front of every compound. So we have the equation to be FeS₂ plus O₂ yielding Fe₂O₃ plus SO₂. So the first thing we want to do is to assign a letter to represent the appropriate coefficients for each compound. So let's assign letter A to stand in front of this compound. Let's assign letter B to stand in front of this compound. Let's assign letter C to stand in front of this compound, and let's assign letter D to stand in front of this compound. Now, someone might be confused and saying, where did these letters come from? Well, these letters are simply representing the coefficients that should stand in front of each compound. So when we balance the equation, for instance, and let's say, I'm just assuming now, let's say we balance the equation and we find out that the balanced equation is 2FeS₂ plus O₂, then yielding 3Fe₂O₃ plus SO₂. What we're simply saying is that we've used the letter A to represent this number 2, since we don't know what the appropriate coefficient is as at now, and we're using the letter B to represent the coefficient here, which is number 1, and we're using the letter C to represent the coefficient here, which is 3, and then we're using the letter D to represent the coefficient. So that's what we're simply doing. Since we don't know what the appropriate coefficients for balancing this equation is, we are representing them using these letters A, B, C, and D. I'm sure you now understand why we did that. So now that we have done that, the next thing to do is to form equations for each element, both for the left and the right side. Let's do that. So the first element that we have is ion Fe. Alright, so now on the left hand side, you can see we have an atom of iron over here. It has no subscript, or its subscript is 1, even though it is not identified. Its coefficient is represented by this letter A. So that tells us that on the left hand side, the number of atoms of iron we have is A multiplied by 1, which gives us A. And on the right hand side, you can see we have an atom of iron over here. It has a subscript of the number 2 and a coefficient of the letter C. So that tells us that on the right hand side, the number of atoms of iron we'll have will be given to us by 2 multiplied by C, which is equal to 2C. And according to the law of conservation of mass, when balancing a chemical equation, the left hand side must be equal to the right hand side. So that tells us that for iron, the equation now becomes A is equal to 2C, equation number 1. Did you get that? I'm sure you did. The next element we have is sulfur. Now you can see we have an element of sulfur over here. It has a subscript of 2 identified here and a coefficient of letter A. So that tells us that on the left hand side, the number of atoms assigned to sulfur is given by 2 multiplied by A, which equals 2A. On the right hand side, you can see we have sulfur over here. It has no subscript, or its subscript is 1, even though it's not identified, and its coefficient is the letter D. So that tells us that the number of atoms assigned to sulfur on the right hand side is given to us by D multiplied by 1, which gives us D. And so equating the two of them means the left hand side must be equal to the right hand side. The left hand side is 2A, which must be equal to the right hand side, which is D. So that's our second equation. The third element we have is oxygen. All right, Oxygen, we have an atom of oxygen over here, and as you can see, it has a subscript of 2, and then it has a coefficient represented by the letter B. So that tells us that the number of atoms of oxygen will be given to us by 2 multiplied by B. That gives us 2B for the left hand side. But for the right hand side, you can see we have 2 occurrences of oxygen. We have one over here and we have another over here. So for the first occurrence of oxygen, it has a subscript of 3 identified here and a coefficient represented by the letter C. So that tells us that we have 3 multiplied by C, which gives us 3C. And then the second appearance of oxygen shows us that it has a subscript of 2 identified here and a coefficient that is represented by the letter D. So that tells us that the number of atoms of oxygen we have in the second appearance is 2 multiplied by D, which gives 2D. So we have 3C plus 2D because they are both on the right hand side. So for the left hand side, we have 2B for oxygen, which is equal to the right hand side, which is 3C plus 2D. This is the third equation. I'm sure you saw how every bit of this was carried out. Alright, now that we have all 3 equations, the next thing to do is to pick one letter and assign a small whole number to it. Let's do that very quickly. Now we have all 3 equations, the first one, the second, and the third equation. So let's pick any letter. If I'm picking any letter, I can pick the letter A, for instance, and I can say let A be equal to 2. So doing that, the first equation, which is A equal to 2C. So since A is equal to 2, anywhere I see A, I put the number 2 instead. So 2 will now be equal to 2C. To find C, I simply divide both sides by its coefficients. So this becomes C is equal to 1. So I found the value of A, which is 2, and the value of C, which is 1. Next thing to do is to proceed to the second equation. The second equation says 2A is equal to D. I know the value of A to be 2. So that means 2 multiplied by 2 is equal to D. Therefore, D is equal to 4. So I have the values of A, I have the values of C, and I have the values of D to be 4. So the next equation, which is the last one, says 2B is equal to 3C plus 2D. I know the value of D to be 4, and I know the value of C to be 1. So therefore, this equation now becomes 2B is equal to 3 times 1 plus 2 times 4. 2B will now be equal to 3 plus 2 times 4 gives us 8. Alright, so 3 plus 8 will now be equal to 11. So therefore, 2B is equal to 11. Therefore, B will now be 11 divided by 2. 11 divided by 2 gives us 5.5. So at this point, I have the value of B, which is equal to 5.5. So at this point now, I can move on to balance the equations. So how do I balance the equation? Well, we have the equation that says FeS₂ plus O₂, giving us Fe₂O₃ plus SO₂. Now remember, at the start of this equation, we assigned some letters: A in front of this, B in front of this, C in front of this, and D in front of this. So now we can substitute the values of the letters to now stand in front of each compound. So A here stands for 2, so we have 2 FeS₂, plus B has the value of 11 over 2 O₂, and then C has the value of 1, so we have Fe₂O₃, and then D has the value of 4, we have 4SO₂. So now we have this equation, but in balancing chemical equations, we do not leave our final answer containing fractions. We want to take away these fractions. So what do? To take away this fraction, we simply multiply everything here by 2, so that this number 2 that stands below 11 can be taken out. So multiplying everything by 2, this now becomes 4, because this 2 multiplied by 2 gives us 4. We have 4 FeS₂ plus 11 O₂, then giving us 2 Fe₂O₃ plus 8 SO₂. This is our final balanced equation. So in order to be double sure, we'll do a quick check to see if each element is balanced on both sides of the equation, the left and the right side. So the first element we have is ion Fe. On the left hand side, you can see ion appears here. It has no subscript, or its subscript is 1 and a coefficient of 4. 4 multiplied by 1 gives us 4 atoms of ion on the left hand side. On the right hand side, ion appears here, having a subscript of 2 and a coefficient of 2. 2 multiplied by 2 tells us that we have 4 atoms of ion on the right hand side. So 4 atoms of ion both on the left and the right hand side tells us that ion is balanced. The next element we have is sulfur. You can see sulfur appears here, having a subscript of 2 and a coefficient of 4. So 4 multiplied by 2 tells us that we have 8 atoms of sulfur on the left hand side. On the right hand side, you can see sulfur appears here, having no subscript, or its subscript is 1 and then a coefficient of 8. 8 multiplied by 1 tells us that we have 8 atoms of sulfur on the right hand side. Sulfur is also balanced. And then finally we have oxygen. Oxygen on the left hand side, you can see oxygen appears here. On the left hand side, it has a subscript of 2 and a coefficient of 11. 2 multiplied by 11 tells us that we have 22 atoms of oxygen on the left hand side. On the right hand side, let's calculate now. Oxygen appears here, having a subscript of 3 and a coefficient of 2. 2 multiplied by 3 gives us 6. That's not the only appearance of oxygen. Oxygen also appears here. You can see oxygen having a subscript of 2 and a coefficient of 8. So 8 multiplied by 2 gives us 16. So altogether we have 16 plus 6, which gives us 22 atoms of oxygen. So oxygen has 22 atoms on both sides, the left and the right hand side. So this equation is perfectly balanced. One more time, let me write out the final balanced equation. 4 FeS₂ plus 11 O₂ yielding 2 Fe₂O₃ plus 8 SO₂. This, my friends, is our final balanced equation. I'm sure you enjoyed every bit of this video where we unearthed the process of balancing a chemical equation step by step using the algebraic method, from the place where we assigned letters to represent coefficients, to the place where we formed equations for each element, and to the place where we solved them to attain the real coefficients. If you enjoyed this video, please like it, give it a thumbs up, and share to as many people as you like so we can reach more and more minds. That's all for today's video. I'm sure you enjoyed every bit of it, and I will see you in the next one where we get to solve more and more examples and deal with more chemistry topics. My name is David, and I'm the billionaire teacher who takes the mystery out of chemistry so you can make history. I'm eagerly looking forward to seeing you in the next video, and until then, stay blessed.